Hello guys, welcome to my YouTube channel. We're going to be looking at exponentials and logs. So you have encountered exponentials expressions previously in the syllabus. Anything in the form of a to the power of x or y is equal to ab to the power of x. They are all exponential forms. Y is equal to a to the power of x or just ab to the power of x. Y is equal to e to the power of x. We're going to be talking about e in a minute, and these are all exponentials in nature. So we will be learning about this and then the reverse of these, which are called the inverse functions of these, how to inverse these functions, and the sketching of these graphs and how transformations works on these and modeling aspects, understanding the log functions and being able to differentiate exponential functions. These are the key areas there where we're going to be exploring. So the first subsection that we're going to be exploring is about the exponential graphs. So exponentials are either in the form of y is equal to ab to the power of x or y is equal to e to the power of x, depending on the base. The difference between y is equal to ab to the power of x and then e to the power of x is where a and b in these in this formula, in this equation, a and b are constant, which are unknown, where it depends. It varies between graphs to graphs or functions to functions, it depends. But whereas y is equal to e to the power of x, where this e is a specific value, although it's not specific in nature, it's not 2.72, but it's like pi 3.14 and then etc, etc, etc. The value keeps continuing, and this is called an Euler's constant, where it was discovered by a mathematician called Euler. We will be looking at e to the power of x graphs. They are exactly the same as ab to the power of x graph. The only thing is that this e is a specific value in nature, and therefore there is that value. The e is not an unknown value, but it's a known value. But whereas ab to the power of x, a and b are unknown, and it depends. If I give you y is equal to 5 times 2 to the power of x, this one is known, where a and b are known. Okay, so we'll draw graphs now. Let's start with a simple one. Y is equal to 2 to the power of x. If you think about y is equal to 2 to the power of x, the graph is going to look like this. That's your x-axis, that's your y-axis, and then the graph is going to be like that, and it would pass through 1. How do I know it's going to pass through 1? The y-intercept is when x is equal to 0. If I put x as 0, y is equal to 2 to the power of 0, and 2 to the power of 0 is 1. And is there an x-intercept to this functions? X-intercept happens when y is equal to 0. Let's make y as 0, 2 to the power of what is 0, and there is no such value for x that would satisfy the equation 2 to the power of x to be 0. So x cannot be any value, and that's why it creates an asymptote when y is equal to 0. So when y is equal to 0, there is an asymptote in any graph of nature. Y is equal to a to the power of x. So y is equal to a to the power of x. Y-intercept is going to be always 1, and then there's going to be an asymptote. Y is equal to 0. If you were given y is equal to 2 to the power of x plus 5, then in this one, I'm seeing a transformation there. There is 8 golden transformation rules that you should know for your syllabus, and I'll list them all in a minute. But this graph is gone up by 5 units. So originally the graph was going through 1. Now the graph will be going through 6. And originally there was an asymptote when y is equal to 0. Now there is an asymptote when y is equal to 5. So there's an asymptote, and then the graph will go through like that. So before we delve into the transformations of these graphs, I need to make sure that you all understand the 8 transformation rules. So the very first transformation rule is if a function is transforming as a function plus a, then the graph is moving up. If a function is moving by a minus in here, then the graph is moving down. If a function is moving with minus a, apologies, if it's moving minus a within the brackets, a lot of people do not understand the difference between this, the plus, and then the minus outside the function, as opposed to inside the function. Outside the function is telling us if you have a function originally as x squared, and then if I say the function is getting added by 5, then that means x squared plus 5. So you just add 5 additionally on top of the function. But if I have a function as x squared, and then I'm just adding 5 to the x, now the function is asking us to replace every single x by 5. So therefore, the graph is going to become x plus 5, the whole thing squared. So the complete equation is changing here. Here, the complete equation isn't changing. All we are doing is we're just adding 5 to the function. So in this case, the graph is going to move to the right-hand side by, so it's going to move to the right by a units. And lots of people have a doubt in this specific area as well. They think if it's minus, it moves to the left, but it's not the case. If it's minus, then it moves to the right, and if it's plus, it moves to the left. So the next rule is if a function is becoming fx plus a, then the graph is moving to the left by a units. Let's say if a function is becoming a fx, this one is vertically stretched, so the graph is vertically stretching by scale factor a. But if in case, if I give you ax within the bracket, so every x is becoming now ax, this is horizontally stretching, but by scale factor 1 over a. If I say that the graph is moving minus fx, here it's a reflection on x-axis. That means if you have a graph like that, and then if that graph is just reflecting, it will become like that. So reflection on x-axis, x-axis acts as a mirror. If you were given the function is becoming f minus x, then it's a reflection on y-axis. That's all the rules that you need to know for transformations. And using these transformations, you should be able to calculate or draw graphs in any sort of questions. Trying to interpret the graphs is quite easier if you know and if you understand these 8 transformation rules.